Hi there, geometry students. Welcome back to Chapter 4. We're looking at Section 4.2, Angles of Triangles. So we are going to be looking at the interior angles and exterior angles and doing some figuring. Notice it says up here in our objective, we're going to find the measures of angles. So we're going to be doing some math. And we need to know triangle sum theorems and other things in order to do that math. So first of all, I already mentioned an exterior angle. Hopefully you realize that that's going to be outside. Specifically, it's going to be an angle formed by one side of a triangle extended, and it's adjacent, then that adjacent angle. So for example, this diagram that I have down here, I've got this little triangle, and notice this bottom side is extended, and then that makes this an exterior angle. Angles 2, 3, and this unnamed angle are interior angles. So if we've got an exterior angle on the outside of the triangle formed by extending one of the sides, the remote interior angles are the two angles that are not adjacent to the exterior angle. So in this particular case, the unnamed interior angle, we could call it angle 4 if you wanted. Angles 2 and 3 are remote interiors. Think about using a remote control at home so you don't have to get off the couch. So your exterior angle, angle 1 sitting out there, and 2 and 3 are the remote interiors. They're farthest away. You don't want to get up and have to walk over there. 4 is attached to it, right? That's right next door or adjacent. I got to just say this. We've talked about postulates and theorems. We haven't memorized what they are. However, I have to make sure I tell you it's just one more terminology thing. A corollary is a statement that is easily proven by a theorem. We won't prove it. We're going to take these things as facts. So we already have talked about, say, the Pythagorean theorem. That's a fact. Or different postulates, and now we have corollaries. I'm not going to quiz you on that. I'm going to expect that you know how to use these things, and we won't question them. So we've got a few theorems to talk about. Triangle sum theorem is a good one. You might already know this. I hope you do. The sum of the interior angles of a triangle equal 180 degrees. The sum of the three interior angles equals 180 degrees. So if I draw a triangle over here, I'm going to draw an obtuse triangle. Let's say that this is 110 degrees, and this is 30 degrees, and this is x degrees. We could now figure that out, right? If the sum of the three angles of a triangle equal 180 degrees, 110 plus 30 is 140. So there are 40 degrees left for that angle. Or we could say x plus 30 plus 110 equals 180. It's probably easier to just jump right to your calculator instead of setting up an equation like that. The only reason I set it up like that is because it's not always just going to be 110 and 30. Maybe one angle is 2x plus 7, and one angle is x minus 19, and one angle is 3x. We add all those expressions up and make them equal to 180. The exterior angle theorem is 97% of the time a shortcut. Here's what it says. The exterior angle is equal to the sum of the two remote interiors. Exterior angle is equal to the sum of the two remote interiors. So if I draw myself a triangle with an exterior angle, so remember the exterior angle has to be the one that is an extension of one side of the triangle and it's outside. So if I said, okay, well, I want to know what the measure of this outside angle is. And I know that this angle over here is 60. This angle is 50. That's all I know. We could do this two ways. We could figure out this angle over here if you wanted to. And then we could say, well, those two angles are supplementary, so subtract from 180. Or we could say the exterior angle x is equal to the sum of the two remote interiors, so the two angles farthest away, 50 plus 60, so x is equal to 110 degrees. It's just a shortcut situation 95% of the time. Sometimes they'll throw something in there that you actually have to know that and use it. Last but not least, there's two triangle sum corollaries. Again, don't worry about a corollary. We're going to use these things as needed. We're not going to prove them or anything else. The first thing that you need to know is the acute angles of a right triangle are complementary. The acute angles of a right triangle complementary. What does complementary always mean? 90 degrees, right? Hopefully you've got that memorized by now. If you think about this in a common sense way, it's going to make sense. Let me draw a right triangle. Even if I'm a bad drawer, if I put that right angle there, you have to believe me. How many degrees are in a triangle? 180, right? That's what we said the triangle sum theorem is. The sum of the three interiors equals 180. Well, let's say that I make this angle 35, and this is x. Probably a bad drawing, but that's all right. So we know that we could do 35 plus 90 plus x equals 180 degrees. That's the triangle sum theorem. This corollary says that, well, if I take this 90-degree angle out, the 35 plus the x have to be equal to the 90 degrees that are left. So again, just another little shortcut. Some people catch on to that and really like it. Some people just use the triangle sum theorem. Any way it goes, I'm pretty sure that x is going to end up being 55 degrees. So another shortcut. And then this one's an interesting one. Again, it's one of those ones, if you think about it, the last thing we should talk about, there can be at most, one right or one obtuse angle in a triangle. At most. So let's talk about an obtuse angle. So basically it's saying if I have one obtuse angle, can I have another obtuse angle? Let's say this is 100 degrees. And a triangle, right? If I got to connect these sides, could I have another obtuse angle, another degree over 90 degrees? Well, if I tried to put another obtuse angle in there, say another 100 degrees, how many degrees am I up to now for this triangle? 100 plus 100 is 200, but how many degrees am I allowed to have in a triangle? 180. I just can't make that happen. The three angles have to equal 180 degrees. Just like in a right triangle, if I'm already using 90 degrees and I put another 90-degree angle in there, how many degrees have I used? That's 180 degrees, but it's only two angles. I don't have another angle that I can put in there. So degrees-wise, it does not make sense. And if you look at the diagram, there's no way I can possibly make a triangle out of the shapes that I just created. They will never intersect, so we don't have any kind of triangle there. All right, so let's do a couple of problems, a couple practice. So this is going to be a lot of figuring out using your calculator. In practice 1A, we've got ourselves a diagram. It says find the missing angle measures. So it looks to me there's an angle 1, an angle 2, and an angle 3. Notice 1, 2, and 3 are angles. They don't have a degree sign on them, so they are angles. We could put x, y, and z there if we really wanted to, and that's what we would need to find. So probably starting with angle 1 would be smart, because if I look at angle 1, it's a part of a triangle, right? It's a part of that triangle. And what do you know about the three angles of a triangle? Those have to equal 180 degrees. So I could do a little quick math here, calculator math maybe. I know that whatever the leftover from 180 degrees from my 43 and 74 is going to be my measure of angle 1. So we could say angle 1 plus 43 plus 74 equals 180. Perhaps you're going to just jump right to your calculator, and I think that comes out to a 63. Double check them. Is 63 plus 43 plus 74 equal to 180? Angle 2. Usually they'll go in the order in which you give them. Angle 2, we secretly know. We're going back to chapter 1. Angles 1 and 2 are related to each other. What kind of angles are they? Those are vertical angles, right? They're formed by two intersecting lines. And what do you always know about vertical angles? They are equal. So this has to be 63 degrees as well. And then we can do what we did on the other side. We can say, I've got a triangle over here, one angle 63, one angle 79. How do I find angle 3? Add those two up, subtract that from 180. And angle 3 should be equal to, double check my math, but I think it's a 38. So it's 38 plus 63 plus 79 equal to 180. So a little bit of sneaky stuff. The old stuff is not going to go away, so make sure you remember things like vertical angles, supplementary or linear pairs, and now we add in that triangle sum theorem. Let's go over to problem number 2. Let's try this one. Find the measure of each numbered angle. I actually put 1 through 5 over here. Notice 1 through 5 are just angles. They are not degrees. Angle 1 is a sneaky one. You can do this the long way or the short way. Do you have a preference which way you want to do it? No preference. Whoops. If I look at this part of the diagram, stretched it out a little bit, but ignore the 2. Angle 1 is an exterior angle if you ignore the line that's going up diagonally. So if I just take this out for a second, I'll put it back in, I promise. But if I take that out and get my pen out, ooh, not that. Get my pen out again. Angle 1 is an exterior angle. We have two options. You can do 50 plus 78, subtract that from 180. That would give you the third interior angle. And then those two guys are a linear pair or add up to 180, so subtract from 180. If you're paying attention to what I said, I just said you should subtract from 180 and then subtract from 180 again. Exterior angle theorem is a shortcut for that. Angle 1 is equal to 50 plus 78, the sum of the two remote interiors. So 50 plus 78, which ends up being 128 degrees. I'm going to take out the white out that I put up there. So we just found angle 1 is 128. Angle 2, it looks to me like angles 1 and 2 are supplementary, right? They form a straight line if I ignore the whole rest of the diagram. So angle 2, if it's supplementary, they add up to 180. So if I do 180 minus the 128, that should get me the measure of angle 2. I believe that's going to be 52 degrees. So this guy right here, 52. Maybe you skip angle 3 for a minute because I see angle 4 over here. Angle 4 and the 120 degrees, those two guys are supplementary. Do you see that these are making up a straight line? If I go from the 120 and to where angle 4 ends, that's a straight line, 180 degrees. So maybe you go to angle 4 is equal to 180 minus 120, or 60 degrees. Angle 5, I'm kind of going in a weird order. I just totally missed angle 3. Let's come back to it. If you look at angle 5, perhaps you see that angle 5 is an exterior angle. When I take the rest of that triangle or figure, whole diagram out of there, I've got 60 and 56 as my two remote interiors. You have two options. You can do 60 plus 56, add those guys up, subtract from 180 to get the interior angle, and then subtract from 180 again to get angle 5. Up to you how you want to do that. I'm going to do what I think is the easier way, and I'm going to do the remote interiors. Add those guys up. So angle 5 is equal to 56 plus 60, or 116 degrees. I'm not sure why I skipped angle 3, but we can go back to angle 3. Check that one out. Let's see. I'm going to use a vertical angle here. I know that angle 4 was 60, so I know that its vertical angle is also 60. So now maybe that middle triangle, if I use the Triangle Sum Theorem, whoops. There we go. If I know that the two base angles there, angle 2 is 52, and the one supplementary to 120 is 60 degrees, I could do 52 plus 60, subtract that from 180, and then I've got myself an answer for angle 3. So 180, I'm going to subtract the 52 plus 60. I don't know if you like the way I wrote that or not, but you can do it different in your calculator. What's that come out to? I think a 68. So we've got ourselves a diagram filled out. Let's do one more example. Let's do number 3. And then I'll quit. So number 3, this is one of those 5% of the time where you have to know the exterior angle theorem, because it says to find the measure of angle FLW. So I'm going to want to know the measure of this whole angle right here, right? Well, 2x minus 48 is not enough of an answer. I want to know an actual number. So that means I'm going to have to be able to figure out what x is equal to. So that means my remote interior angles are x and 32, right? So my exterior angle equals the sum of the remote interiors. So 2x minus 48 is my exterior angle. My two remote interiors, not adjacent to that highlighted angle, are x plus 32. So now I've just got myself an equation to solve. The hardest part was setting up the equation, and that's the tricky one because we don't use this one very often. That's why I wanted to do an example where you had to use the remote interior angles. So let's see, I'm going to minus x from both sides. I'm going to add 42 to both sides. Oh, no, sorry, 48 to both sides. And I think that's 80. X equals 80. Are we finished with this problem if we know that x equals 80? We're not, right? Because it said to find the measure of angle FLW, so this whole angle. So I'm going to take that 80, and I'm going to plug it into the x. So FLW is 2 times 80. Minus 48, so 160 minus 48 is something like 112 degrees. There's the measure of angle FLW. So some sneaky problems, lots of calculator work and math, solving equations like we had to in this one. That's why I kept writing that a little bit differently instead of just saying I'm going right to the calculator and I'm adding things up, because we can have expressions like 2x minus 48. So that is the end of section 4.2. Thanks for hanging in there. Bring any questions that you have. I'd love to talk them through, and let's do some problems. These are like puzzles, so it's kind of fun to figure out what goes where and how many degrees and how are things related. So thanks, and see you next time.